Even on small, light aircraft, a method of precisely locating each structural component is required. Various numbering systems are used to facilitate the location of specific wing frames, fuselage bulkheads, or any other structural members on an aircraft. Most manufacturers use some system of station marking. For example, the nose of the aircraft may be designated as the 0 station, and all other stations are located at measured distances in inches behind the 0 station. So, when a blueprint reads Fuselage Frame Station 137, that particular frame station can be located 137 inches behind the nose of the aircraft. To locate structures to the right or left of the center line of an aircraft, a similar method is employed. Many manufacturers consider the center line of the aircraft to be a 0 station from which measurements can be taken to the right or left to locate an airframe member. This is often used on the horizontal stabilizer and wings. The applicable manufacturer's numbering system and abbreviated designations or symbols should always be reviewed before attempting to locate a structural member. They are not always the same. The following list includes location designations typical of those used by many manufacturers. Fuselage stations, fuse, stay, or FS, are numbered in inches from a reference or 0 point, known as the reference datum. The reference datum is an imaginary vertical plane at or near the nose of measured. The distance to a given point is measured in inches parallel to a center line extending through the aircraft from the nose through the center of the tail cone. Some manufacturers may call the fuselage station a body station, abbreviated BS. So, the Buttock Line, or sometimes called the butt line BL, is basically a vertical reference plane that runs right down the center of the aircraft. It's used as a starting point from which, measurements to the left or right can be made. Waterline, or WL, is the measurement of height in inches that's taken perpendicular from a horizontal plane. Usually this plane is located at the ground, the cabin floor, or some other spot that's easy to reference. Aileron Station, or AS, is measured outboard from and parallel to the inboard edge of the aileron. It's taken perpendicular to the rear beam of the wing. Flap Station, or KS, is measured perpendicular to the rear beam of the wing and parallel to and outboard from the inboard edge of the flap. Nacelle Station, which is abbreviated as NC or sometimes NAC. Stay is measured either forward of or behind the front spar of the wing and always perpendicular to a designated waterline. In addition to the location stations we've talked about, there are, other measurements used, especially on large aircraft. So, there might be horizontal stabilizer stations, or HSS, vertical stabilizer stations, VSS, or even power plant stations, PPS. In every case, it's really important to check the manufacturer's terminology and station location system before trying to locate a point on a particular aircraft. Another method is used to facilitate the location of aircraft components on air transport aircraft. This involves dividing the aircraft into zones. Large areas or major zones are further divided into sequentially numbered zones and subzones. The digits of the zone number are reserved and indexed to indicate the location and type of system of which the component is a part. Knowing where a particular structure or component is located on an aircraft needs to be combined with gaining access to that area to perform the required inspections or maintenance. To facilitate this, access and inspection panels are located on most surfaces of the aircraft. Small panels that are hinged or removable allow inspection and servicing. Large panels and doors allow components to be removed and installed, as well as human entry for maintenance purposes. The underside of a wing, for example, sometimes contains dozens of small panels through which control cable components can be monitored and fittings greased. Various drains and jack points may also be on the underside of the wing. The upper surface of the wings typically has fewer access panels because, a smooth surface actually promotes better laminar airflow, which is what causes lift. On large aircraft, Walkways are sometimes designated on the wing's upper surface to allow safe navigation by mechanics and inspectors to critical structures and components located along the wing's leading and trailing edges. Wheel wells and special component bays are areas where, numerous components and accessories are grouped together for easy maintenance access. Panels and doors on aircraft are numbered for positive identification. On large aircraft, panels are usually numbered sequentially, and the numbers contain both zone and subzone information. The designation for a left or right side location on the aircraft is often included in the panel number. This could be with an L or R, or sometimes panels on one side of the aircraft are odd numbered and the other side even numbered. The manufacturer's maintenance manual explains the panel numbering system and quite often has numerous diagrams and tables showing the location of various components and under which panel they may be found. Each manufacturer is entitled to develop its own panel numbering system.